last module we discussed about the format of SRv6, wherein we discuss about the SID format, divide in three part of it, and then one is locator, function, and argument, wherein function locator is basically a routable part. Function will tell us what to do with that, what function to perform, and argument is basically how to fine grain that. Today we'll discuss about the SID block. So what is SID block? So whenever we have a topology, let's say, and based on that topology, let's say your internal network is there, and then based on that, for your infra link and for your internal network, you assign an IPv4 subnet to it, right? So based on that subnet, you assign that point-to-point network or assign the server addresses. So in order to deploy in SRv6, we need to assign a subnet as well, the same thing, right? So what is basically exactly same as when IPv4 we are talking about. In an internal network, when we have assign a subnet in terms of an IPv4 network, that subnet is being used based on your point-to-point network or based on your internal servers, everything, all the infra links, everything, right? For example, when the same thing we talk about with IPv6, we need to assign a subnet. For SRv6, we need to assign a SID block, a subnet, which required to assign to each and every node. So when we assigning to each and every node, so that means every node will have one block of subnet. So from that block, basically we will be assigning, we'll use this block, and then we'll assign to each and every node in the segment routing environment. So for example, I will use this block, and then I will use this node ID to make it unique with respect to router 1. Similarly, for router 2, I'll assign 2. Router 3, I'll assign 3. You can assign anything, but that should be unique to that particular router. So based on this, we will have a block, and then based on this block, we'll have a node ID, and which makes it unique. So as for RFC, we will have a SID block. With SID block, we will have a node ID as well. So the locator is a SID block plus a node ID, which will be used as a whole as a locator in order to find the network, find the router basically. So this is what the locator is. So locator belongs to one node, and that should be unique. So if you see that in the topology, everything is unique. All the locators are unique. So for example, if I want to go from 1 to 6, I know which locator to use to go to 6. So locator will give us an instruction to forward the packet to a shortest path. So from 1 to 6, how the shortest path is, I'll go with that. And then it's a SID. When the packet reaches to the endpoint, it will see the next as function, and the function will give us the way in order to what function need to be performed. So this is what basically this SID block is, and this is what based on from the SID block we'll have a locator with a node ID. The question is how to advertise this SID block. How R1 will come to know about R6, or R2 will come to know about R4, everything. How we can distribute this. Similar to our network, internal network, we do that distribution using an IGP. So IGP, ISIS or OSPF will use to advertise this locator, which is our routable prefix. And this routable prefix is basically a locator. So in order to reach, we'll use locator. Second question is, how many locators can we configure? 1 locator, 2 locator. So we can configure multiple locators. So that depends on the use case. If we have a Flex Algo, then we can have 1 locator for Flex Algo, another one for normal routing. So we will have a SID block. Now we can divide this SID block into a SID block, as well as we can assign something which is basically a particular region based, or we can assign for example, let's say a Flex Algo. So /32, we will take it as a SID block. Remaining 16 bits, we will take it as a Flex Algo and region if you want to do it. So we can divide 8 bits of each. So 80 is assigned to the Flex Algo, and 01 is assigned to the region. So that this is also we can do a assignment of a locator to a device. Now, for example, we have 2001 db8/32 is my SID block. 8001/64 is my Flex Algo with region, and then 001 is for my node ID. So we can divide this one as SID block, which is reserved. This address, basically I reserve it for SID block. Second, the 16-bit octet, I reserve it for Flex Algo and region. And then the next one, let's say 001, or let's say 005 or 006. So this is basically for my node ID. And now the next one. So this combination of total 64 bits is a locator. So for example, if it is 005, then this is my locator is. Once a packet reach at R5, what will happen? It will check the function. What is the function is saying? What action I need to perform? Based on the function, I will perform the next action. And then remaining bits are being used for argument. Right? So what instruction once the packet reach at the destination? The destination is in our case is 6. It's not about 6. It's about reaching to R5. So R5 is also when the packet reach SRv6 packet reach there, then what will happen? So what function need to provide? Where it will traversing the packet, whether it will sending to a neighbor or any next hop, or I can pass the packet to the VPN. So this is how it will be defined. This what instruction that function will be, or pop the outer label, or pop the outer packet and then forward the native packet, right? So we can pop the SRh and then forward the native packet, whatever is encapsulated. That is also possible with an function. So the remaining bits which are been there is argument. So basically argument is nothing but it's a way in order to we can do a fine grain behavior. And we know that argument is basically all zeros, rarely used. So next we'll see the lab.